Okay, so I have no idea how to move my video screen. I'm recording. So just bear with me, kids. I'm going to figure it out. I'm going to try my best. If you can't figure it out, hopefully your sub today is a math teacher. So hopefully they can help you guys. So let's get to today's lesson. Tomorrow's going to be the 22nd. No, I didn't. Here we go. It was right at the top. Okay, so if you haven't finished the 3-act math, make sure you get that finished. To either today or tomorrow. You can either do it today, tomorrow, because I'm not going to make a part 4 because we're just going to be pretty much done with Over the River and Through the Woods as of right now. Okay, it just depends on the feedback I get from the sub. So that's what we're going to be doing. So let's get started. This one isn't going to be as long. We'll start the slideshow. Okay, so what we're going to be doing is I'm going to be introducing to parabolics. So we're going to start with this. So you're going to use the equation y equals x squared to complete the table of values in the graph. So what you could do is you could put this in your calculator. You could do that, or you could just, what I suggest, and what I've been in training all day, is you're going to be doing it by hand. That's the best way to do it. So don't even rely on that calculator if you don't have to. Okay. So we have -3 here. And you're going to do -3 times -3, and you're going to get 9. Yeah, just like that. Then you're going to have -2. So you're going to plug this into the equation. -2 times -2 is 4. -1 times -1 is 1. -1/2 and -1/2. I like to do -1/2 and -1/2. It's going to be positive 1/4. Okay, so you can do 1/4. I know I turned that decimal into a fraction because I like fractions better. But we know that positive 1/4 is also equal to 0.25. Okay, so those two are the same. 0 times 0 is also 0. 2 times 2 is 4. 2.3 times 2.3. Now for this one, you can't get your calculator out. I'm just going to do it by hand real quick. 2.3, 2.3, 9, 6. And then I'm going to have my x here. And this is going to be 6, 4. Then I have, I'm running out of room. 9, 2, carry the 1, I have 5. And then my answer has 2 decimal points, so it's going to be 5.29. Well, that was a little bit aggressive. And then we have 3, which is going to be 3 times 3, and that's going to be 9. Okay? And that's what that's going to look like. Yes, it's ugly right now. And if you want to pause the video, you can pause the video. I'm going to trash this. And I'm just going to click on it. And I'm going to have it magically filled in. Look at that. Okay? And that's what y'all's outputs would be. That's what your y values would be, depending on your x. And then you can plot these points. So you can plot these points like this. I have -3 here, and then we have 9 all the way up here. Bam. We have -2 and 4. That's what that looks like. I have -1 and 1. That's going to be here, if you can see them. Then I have 0, 0. I have the origin. And then I'm just going to be doing whole numbers. I'm not going to be worried about these rational numbers. I'm just going to work with the whole numbers. 2 and 4. Let's see, we're going back up here. Woo. And then we have 3 and 9. As you see, this is making a parabolic curve. And one thing I did put on this slide is I think is pretty cool is that you do see parabolic curves. It's not as direct, but if you look at the Margaret Hunt Bridge in downtown Dallas, you'll see that it does make a parabolic curve as well. So you do see them in real life. How interesting. Okay. So here I want to show you that that is what it looks like, and that's what you should have, something similar to this. Okay, so if you need to pause the video, you can pause the video and you can draw this on your notes. And this is y'all's introduction to parabolics. How fun. Okay, so does this graph represent a function? Explain your answer. Yes, this does represent a function because this graph passed the vertical line test. There was no repeating x values. So yes, this represents a function because the x values do not repeat. Okay. Quadratic function is a function that can be written in the form of y equals ax squared plus bx plus c, where a, b, and c are any numbers. A is not equal to 0. Okay, so this is your introduction to quadratic function, and these functions make your parabolic curves. Okay, they're really important, especially when you're going into Algebra 1 next year. You're going to be seeing a lot of ax squared, bx, and c. And guys, let me tell you, I was in training today, and that's all I did today. And you really have to be really good at mental math. I mean, my teacher was making us stand up and just repeat square values from memory all the way up to 25. I'm not going to tell you how far I got, but it was intense. All right. So A would be 1, B would be 0, and C would be 0. So those are some of the examples that you could use. So the values of A, B, and C are all real numbers. The values of A is not 0, so it contains the term x squared. Okay, these are just definitions. I know it's a lot of front loading. A lot of these quadratic formulas are just basically practice, and especially knowing your basic mental math skills like your times tables, being able to divide in your head. The key to success with Algebra 1 is basically being strong at your fundamental math. Okay, you have to be strong there. Okay, so that's what I'm going to be showing you guys. Mental math skills. But for this one, I'm going on with mental math. This is to the cubed root. So this might not be as mental math as you think. You're going to might need the assistance of your calculator to do this. And let me pause this and see if we can pull our TI-84 up. Okay, so I'm going to get the TI-84. And as you guys know, if you guys have an iPhone, you go to Calculate 84, get that app on your phone, and you don't have to spend $200 on getting a new calculator. So what you guys are going to do is you're going to plug in your x value here, so x, and then you're going to put it to the cubed root. So you're going to put it up to 3. Okay. Once you have this there, you can do second graph, and then you get your values. Okay. So what do we have? -2. So I'm going to go up here to -2, and we see the cubed root of -2 is -8. Okay, and we could look. We have -1.5. You can. I'll tell you what that is. You can skip that for now. Let's look at these whole numbers. We have -1. That's going to be -1. We have 0, that's still going to be 0. We have 1.5, that's a rational number. And then we have 2, which is going to be 8. So let's plot the whole numbers first. Okay. And if you guys need to rewind this part, definitely rewind it. I'm not going to be slowing down because this is a video and you can pause, record, and do all that stuff. So you'll be all right. So I'm going to minimize this and we'll go back to the slideshow. Oh, I didn't fill these in. Oh, I didn't finish this thing. So let me go back to the calculator. I'm going to do it as we go. I stopped getting fancy, guys. I'm sorry. -8. So we have -8, -1, 0, and 8. And I'm just going to plot these whole numbers. Now, the math teacher is there, so if she wants to go ahead and do the rationals, it's really good practice. You can put them in there. But for me, and for me being in math class all day, the best thing is just to work with the whole numbers, okay, especially when you're working with functions. -1, -1. And be aware of the number line because this one is not numbered the same. And then this one is going to be 0, 0, which is of the origin. And I did not want my circle to be that big. My goodness. It's huge. We had 0, 0, the origin right here. And then we're going to be at 2 and 8. And you see how this one is different? So if I were to draw this, this is going to be making some funky ass, some S-like shape. So it's half the curve in the positive quadrant 1, and the other half the curve is going to be in quadrant 3. Okay, so it's going to be making an S. That's a really ugly S, but it makes an S. Okay. Okay. Something kind of like that. I'm trying to clean it up a little bit, but it's making that curve. Let me close this. Does the graph represent a function? Explain yes. And this would represent a function. Okay. This would represent a function because your x values are not going to be repeating. Yes, because your x values do not repeat. I'm just going to be writing on here. Bam. Okay. All right, I'm going to erase this and we're going to move on to the next slide. Okay, so here we're going to be working with this. So if a family had flown, they would have traveled 2,100 miles and spent $3,250 on tickets alone. Compare the cost per mile for flying and driving to determine the independent and dependent quantities. Oh, that was it. That's it for today, guys. You guys are finishing up on analyzing linear functions. So, guys, this is going to be the end of the slide. The rest of that stuff is that was stuff we did last time because I remember that question. I'm going to X out the slides. So, go ahead, finish the 3-act math. And once you're finished with the 3-act math, go ahead, finish Over the River and Through the Woods. And then once you're done, I'll have a new new presentation for you guys on Thursday. All right. Hope you guys are doing well. I hope you guys enjoyed field day. I miss you guys and have a great day. Bye.